Greetings, fellow grade 12s. It is still Mr. Shajai here. Welcome to Back to Basics, right? So, we are doing arithmetic series now from grade 12s, right? So, please ensure that you have watched some of the videos on arithmetic sequence and all the introductory videos so that you are in a position to understand some of the things that we are going to be doing in here, right? But welcome. Glad that you are here. Now, let's look at this one. So it is a past exam paper from the KZN province. This was from the year 2024, right? Isn't it right? Now, so let's look at now the question that we are given here. They are saying here you are given a finite arithmetic series, right? So I think now when they say a finite, which means now it's basically a series whereby you know the last term, or rather you know where it ends, right? Remember, because infinity, it is, it's endless, right? Which means now when they say finite, which means this particular, series ends somewhere, right? Which means it consists of your last term, right? Now let's look at 3.1.1. Now they want us to determine what is going to be the general pattern of it in terms of dn plus c, right? So what is the first thing that you are going to do now? From here, we are going to start from here, right? Remember here you are having 9. This is 9 plus 14. This is plus 19, right? Plus continuously up until 1, 2, 4, right? Now, what is that you're going to do now from here? You're going to find out what is the difference here, right? So you're going to say 14 subtract 9. What is 14 subtract 9? You are going to get that this is 5. When you say 19 subtract 14, this is 5, which means now your difference that you're having here, it's going to be 5, right? Thereafter, which means here you are going to have Tn is equals to A plus, this is going to be same as N subtract 1, then this is going to be D. Now, what is your first term here? This is 9 plus, this is N subtract 1. What is the difference here? This is 5. Oh, it's get right now. What is that you're going to have here? This is going to be 9 plus, this is going to be 5, N subtract 5, which means now your Tn here, it's going to be same as 5N plus 4, right? 5n plus 4, which is going to be your Tn of this particular, formula. Now, from here, let's look at 3.1.2 now. They want us to write the series in sigma notation, right? In sigma notation. Now, what is it that you are going to do now if you want to write this in sigma notation? Firstly, we need to know in terms of how many terms are we having here, right? In this particular arithmetic series, we need to know how many terms are we having. So which means now for us to do our 3.1.2, we are going to start by firstly finding out how many terms are we going to have here, right? So which means we are going to take the last term, which is 124, right? We are going to say, remember here it is Tn is equals to 5n plus 4, right? So now we are going to write in our 124 here is equals to 5n plus 4. Are we together? Then you are going to substitute, we are going to now, transpose here, right? So which means this is going to be same as 120 is equals to 5n. You divide by 5, we divide by 5 here, which means now your n is going to be same as what? This is going to be same as 24. Okay, so which means now when we write our sigma notation, what is that you're going to do now from here? You're going to say, look, our sigma, right? It's going to be same as what, right? This is going to be same as where n is equals to 1, right? N is equals to 1. And then here, how many n are you having here? Remember, here it represents the number of term, which means here you are going to have 24 terms. And then here it represents the Tn formula, which is going to be same as 5n plus 4. Let's get. So basically now, this is how you are going to go about in writing your sigma notation, right? Remember, you cannot equate it to your SN because you don't know in terms of what is the sum of all the 24 terms. You haven't calculated it as yet, right? So basically now, that's what you are going to have here. Alright, again. So I am hoping that all of this makes sense, right? Now, let's look at your 3.2. Now, in your 3.2, they want us to prove that in any arithmetic series in which the first term is A and whose constant is D, the sum of the the first nth term is given by Sn is equal to n over 2 into bracket 2a plus and subtract 1d, right? Now, what else then that we are going to have here now? To prove this, right? To prove this, I want us to start here. Now, let's say for an example, I give you S, right? Now, let's just say I give you S here. For an example here, let's say I give you a sum of numbers up until, let's say up until, 100, right? So which means, can you see that this is going to be 1 plus 2 plus 3 plus 4 continuously up until probably 99 plus 100. Oh, it's again. Oh, it's again, right? So, and now I want you to look at something, right? Remember, in the same numbers, right? Let's say now I write another expression, the sum of numbers. However, now I am starting backward, right? So, which means now I'm starting from 100. This is 100. This is going to be, right? This is going to 100 plus 99 plus continuously up until, let's say, now I'm beginning with, right? This is going to be my 2, and then this is going to be my 1, right? Altogether, right? Can you see what I did here? I just simply wrote this expression backward, right? Now, I want you to look at something. Now, so if let's say now I want to add these two, right? These two examples, what is that I'm going to end up having here, right? Look, so which means now 101 plus 100. What is that I'm going to have here, right? S plus S is going to give me 2S, isn't it, right? So which means when I say 100 plus 101, can you see 100 plus 1, it's going to give me 101, right? I want you to look at something. If I do 2 plus 99, can you see that I'm going to get 101, right? Even if, let's say here I had 98, right? 98 plus 3, it's still going to give me 101, right? So even if I can come back here, right? Even if I can come back here, I'm still going to get my 101 plus my 101. Oh, it's okay. So basically now, which means the sum of all of these is going to give me the same thing, right? Whether I write it from the beginning or I write it from the end, right? So these two both ends are going to give me the same answer, right? Now the same is true. Remember now, in an arithmetic sequence, now if you want to express the first term, right? Remember the first term in an arithmetic series, it is expressed by what? Now, if you want to express the first term, it is given by what? Your S is going to be given by A, right? Now, when you move into the next term, you know that it's going to be A plus D, right? When you're moving to the next term, can you see? You remember that this is A plus A, this is A plus 2D, right? Now, which means now the Tn, if now I can continue up until the last term, right? Let me just make up my space here. Let me just remove this here so that I can write it in a much more spacious area, right? Now, so I am saying now, if I write my term, right, and where does this come from, for an example, right? So if I am saying now my S, I'm representing the first term. My first term, we know that is A, right? The second term, we know that it's given by A plus D. The third term is given by A plus 2D, right? Now, continuously, right? So, and I would know that my last term, right, it's given by the Tn formula. Remember the last term, it's a term that we don't know, right? So which means the last term is going to be given by, this is going to be A plus N subtract 1D altogether, right? And now, if I can say the term before that, what will be the term before that now? Because remember, if this is the last term, right? It is the last term subtract 1, which means now my second last term, it's same as what? A plus into bracket N subtract 2 D altogether. Now, this is going to be my second last term, right? Now, the same is true now. If let's say now I write another expression of sum, right? Now, however, now I am starting from the back and I'm moving forward. What is it then that I'm going to have, right? Can you see that here my S is going to be same as what? A plus this is going to be same as N subtract 1D, right? This is going to be plus, can you see, we said the second last term would be A plus, this is N subtract 1D, right? plus now continuously. Now, what is it that I'm going to end up having here? My last term here, my first term here, it was what? It was A. Now, this is going to be plus A plus D altogether, continuously so, right? And now, I want you to look at this, right? Remember, what is it that we did there previously, right? Now, if I want to add these, right? Sum, right? The sum of nth term. What is it then that you are going to have here? Can you see that the sum of n term, right? This is the sum of n term. If I add my Sn and my Sn here, if I want to add these two, can you see that I'm going to have 2Sn, right? So which means now my 2Sn is going to be same as what, right? Now I am going to add my A plus, this is going to be A into bracket n minus 1d, right? Let me just do this here. If I say A plus, this is going to be same as A plus n subtract 1d. Can you see that A plus A is going to give us what? This is going to be same as 2A plus n subtract 1d. Isn't it so, right? So which means here I am going to have what? 2A plus n subtract 1d, right? Just like how we did here. Remember, if I added my 101 and when I got my 101, right? Even the next term, what I was doing, I was still getting the same answer, right? So which means now, even here continuously, right? Even here continuously, I am still going to get the same answer of what? Of 2a plus, this is same as n subtract 1d, plus so on and so forth, right? Even if you can look at the last term, right? Can you see that even from here, right? Even from here, I am still going to get what? 2a plus n subtract 1d, right? And then now from here, because I want to find out what is going to be my Sn, I'm not looking for 2Sn. What is it then that I'm going to do now from here? What is that I'm going to end up having here? Remember now, if I am adding all of these, right? So all of these, it is going to be added up until the nth term, right? Right? So which means now I can write this, right? Remember, if this is up to an infinite number, right, I can represent that in terms of n, right? So which means now, if I've added all of these, this can give me my n, right? If I'm adding all of these, right? Remember, I don't know in terms of what is going to be the total number of term, right? So I can just represent all of this in terms of 2 plus, this is going to be n into 2a plus this is going to be n subtract 1d altogether, right? Now, and then now from here, if I want to find out what is going to be my, remember this is 2Sn, if I want to find out what is going to be my Sn, then I am going to say, look, my Sn is going to be same as what? I divide by 2 everywhere, right? So which means this is going to be same as n over 2 into what? Into 2a plus this is going to be n subtract 1d, which is the formula that we were required to prove, right? So I am hoping that all of this makes sense and you can be, in a position to understand in terms of what is it that we are required to do in here, right? So thank you very much for listening.